What's immense, seemingly flooded with water, yet drier than the Sahara Desert? Our moon. For centuries, astronomers debated the existence of water on the lunar surface. In a groundbreaking discovery, the SOFIA mission in 2020 confirmed the presence of water molecules in sunlit areas. This revelation has fundamentally altered our understanding of Earth's celestial companion. The SOFIA observations are crucial. They indicate that water is not limited to the shadowed polar craters as previously believed. This has significant implications for future lunar missions. Early astronomers, observing the moon's dark flat plains, mistook them for seas, calling them Maria, Latin for seas. These early observations were based on the limited technology of the time, which couldn't reveal the true nature of these vast plains. They imagined the moon to be a world not unlike Earth, with expansive oceans and perhaps even life. This led to the misconception of vast lunar oceans. The idea of lunar seas persisted for centuries, influencing both scientific thought and popular culture. By the late 1800s, scientific understanding evolved. Advances in telescopic technology and the study of celestial mechanics provided clearer insights into the moon's true nature. It became evident that the moon lacked a substantial atmosphere to hold liquid water. The realization that the moon was an airless, barren world marked a significant shift in our understanding. The moon, it seemed, was barren and dry. This new knowledge dispelled the myth of lunar seas and reshaped our vision of our closest celestial neighbor. However, in the 1960s, a new theory emerged. With the advent of space exploration, scientists began to reconsider the moon's potential for water. Scientists proposed that permanently shadowed craters at the lunar poles could trap water ice, shielded from the sun's heat. This theory opened up new possibilities for future lunar exploration and the potential for sustaining human presence on the moon. The Apollo missions in the late 1960s were a monumental achievement for humanity. These missions in early 1970s initially seemed to confirm a dry moon. The barren, desolate landscape appeared devoid of any moisture. No direct evidence of water was found, and the moon was thought to be an arid world. The 1990s ushered in a new era of lunar exploration. With advanced technology, missions like Clementine used radar signals to explore the moon's surface in greater detail. These signals hinted at the possibility of frozen water in the shadowed polar craters, areas that never see sunlight. This was a tantalizing clue that suggested the moon might not be as dry as previously thought. In 2008, scientists re-examined lunar samples brought back by the Apollo missions. These samples contained volcanic glass beads, and to their astonishment, they found evidence of water molecules trapped within these beads. This discovery revolutionized our understanding of the moon, opening up new possibilities for future lunar exploration, and the potential for sustaining human life on the lunar surface. Section 4. Mapping the Lunar Thirst. The year 2009 marked a turning point. Multiple missions, including India's Chandrayaan-1 and NASA's Cassini and Deep Impact, detected signs of hydration in the lunar soil. That same year, NASA's L-Cross mission deliberately crashed a rocket stage into a permanently shadowed crater, confirming the presence of water ice. Further observations by the Lunar Reconnaissance Orbiter, or LRO, provided detailed maps of water ice distribution in these regions. These findings solidified the evidence. Section 5. A Wellspring of Discovery. The 2020 discovery of water molecules on sunlit portions of the moon by SOFIA adds a new dimension to our understanding. This groundbreaking finding was made possible by the Stratospheric Observatory for Infrared Astronomy, or SOFIA, which is a joint project of NASA and the German Aerospace Center. SOFIA's unique capabilities allow it to detect the faint signatures of water molecules, even in the harsh environment of space. This water is not in the form of ice but rather chemically bound to the lunar soil. Scientists believe that these water molecules are trapped within the mineral grains on the moon's surface, making them more accessible than previously thought. This discovery challenges our previous assumptions about the moon's arid environment. The presence of water on the moon, both in shadowed craters and on sunlit surfaces, has profound implications for future lunar exploration. It suggests that water could be more widespread across the lunar surface than we ever imagined, providing a potential resource for sustaining human presence on the moon. It could potentially be extracted and used as a resource for future missions. This would be a game changer for long-term lunar missions, reducing the need to transport water from Earth and enabling more sustainable exploration efforts. These discoveries underscore the dynamic nature of scientific inquiry. Each new finding opens up more questions and possibilities, driving the quest for knowledge forward. Our understanding of the moon, once considered a dry and desolate world, continues to evolve. The moon's story is far from complete, and each new discovery adds another layer to our knowledge. The moon, it seems, still holds many secrets. As we continue to explore and study our closest celestial neighbor, who knows what other surprises await us in the vast expanse of space.